All right, so we've successfully defined work. And one of the quick things that I wanted to do, that I would like to do, is the following: kind of do a little dimensional analysis on the force, or what mass, mass times acceleration is. What are the units for mass? Right, kilograms. And then what are the units for acceleration? Nope. Meters second squared, over second squared. Okay. So the units here are kilograms times a meter over second squared. Those are our units for force. And we just give this a name, and we honor Newton with that. So N just represents a Newton. So if someone says, man, I weigh 50 Newtons, they're talking about their weight. Man, if I weigh 100 pounds, Newtons and pounds correspond. Newtons and pounds, they're the same, they're measuring the same thing, but it's different standards. So the pound is according to the US customary system of units, and the Newton is the international standard that we use. It's MKS, the MKS system. So we have a Newton. And then, do you guys know the units for displacement? Yep, what are the units for displacement? I go way up here. See this X and this XF, what are the units for position? Very good. The change, displacement is the change in the position. So it's still meters. What about time? What are the units? Very good. Very good. So what about velocity? Velocity, the units for velocity are meters per second. Excellent. Excellent, excellent. What about acceleration? So you know velocity is what? And well, it's so it's meters per second divided by a second. Meters per second divided by a second is just second squared. Well, meters per second divided by a second is just equal to second squared. So let me rewrite this. All right. So we know if we see 3 meters per second squared, we're talking about what? Excellent. If we see 17 meters per second, what are we talking about? What is that a value? What does that quantity, how does it, what does that quantity qualify? Oh, what is that quantity? Yes, yes, thank you, thank you. Thank you all for helping me there. And so now we have, our Newton here, kilograms times a meter over a second. So that's just mass times acceleration. So with that, you see you have work here. What are the units for work? No, what is the sum of the force? What are the